Welcome to this episode. Now let's talk a bit about electric arc furnaces and try to explore together whether this technology could ignite a green spark. As advocates for a healthier planet, experts are always searching for sustainable solutions. In the steel industry, a beacon of hope is at the front line, the electric arc furnace, or EAF. Unlike traditional blast furnaces, which rely heavily on coal, EAFs use electricity to melt scrap metal. This has generated excitement, with many touting EAFs as a green alternative. EAFs promise lower greenhouse gas emissions and reduced reliance on finite resources. The process seems simple. Collect scrap metal, melt it down in an EAF, and voila, new steel. This almost closed-loop system, utilizing recycled materials, paints a picture of a greener future for this essential industry. The image of these furnaces crackling with electric energy is captivating. It feels like a scene from a futuristic movie where sustainability reigns supreme. But, as with many things in life, the reality is more nuanced. While EAFs promises to offer a significant step towards a more sustainable steel industry, it's crucial to look deeper and understand the complexities involved. Are EAFs truly as green as they appear? The term green technology is often thrown around casually. It's a powerful label, evoking images of pristine forests and a healthy planet. However, it's crucial to differentiate between genuine environmental progress and clever marketing tactics. The environmental impact of EAFs hinges on a critical factor: the source of electricity powering them. If the electricity originates from fossil fuel-dependent power plants, the green label loses its shine. In fact, instead of reducing emissions, we're simply shifting the problem upstream. Imagine a scenario where an EAF runs on electricity generated by a coal-fired power plant. The process might appear cleaner at the steel mill, but the coal plant continues to release harmful greenhouse gases. In essence, we're simply relocating the pollution, not eliminating it. This highlights a crucial point. Evaluating the sustainability of EAFs requires a holistic view, considering the entire energy supply chain. To truly understand the environmental impact of EAFs, we need to follow the electricity. Imagine a network of interconnected systems, each playing a role in delivering power to the EAF. Let's start with a coal-fired power plant. The burning of coal releases greenhouse gases, contributing to climate change. This electricity then travels through transmission lines, eventually reaching the EAF, where it's used to melt scrap metal. While the EAF itself might have lower emissions, the overall process is still carbon intensive. Now envision a different scenario: an EAF powered by renewable energy sources like solar or wind. In this case, the electricity generation process is significantly cleaner, resulting in a much smaller carbon footprint for the entire steelmaking process. The takeaway is clear. The source of electricity is fundamental in determining the sustainability of EAFs. Now we'll compare the energy efficiency of EAFs and blast furnaces. Energy efficiency is crucial in evaluating environmental impact. In this regard, EAFs have a clear advantage over traditional blast furnaces. Blast furnaces are highly energy intensive. They need vast amounts of heat to melt iron ore and convert it into steel. This process consumes enormous amounts of coal, releasing significant greenhouse gases into the atmosphere. EAFs, on the other hand, are much more efficient. By using electricity to melt scrap metal, they avoid the energy-intensive steps involved in processing raw iron ore. This means lower energy consumption and smaller carbon footprint. The efficiency of EAFs makes them the environmentally friendly option for steel production. However, it's important to remember that efficiency alone doesn't ensure sustainability. The electricity is the critical factor. The power grid equation is the key to unlock true sustainability. The discussion about EAFs and their environmental impact inevitably leads us to a broader conversation about the energy grid. The carbon intensity of the grid, which reflects the amount of greenhouse gases emitted per unit of electricity generated, is the key to fully determine the true sustainability of EAFs. In regions where the grid relies heavily on fossil fuels, the environmental benefits of EAFs are diminished. The emissions simply shift upstream to the power plants. However, in regions with a cleaner grid powered by renewables like solar, wind, or hydro, EAFs can truly live up to their green potential. Imagine a future where the electricity powering EAFs comes entirely from renewable sources. This would be a game changer for the steel industry, allowing it to produce this essential material with a significantly reduced environmental footprint. The transition to a clean energy grid is essential for unlocking the full potential of EAFs and creating a truly sustainable steel industry. Let's talk about the importance of a holistic approach for steel sustainability. The journey towards a greener steel industry demands a comprehensive approach. It's about transforming the entire system, not just adopting EAFs. Investing in renewable energy is crucial. Shifting to cleaner sources like solar, wind, and hydro. This reduces the carbon footprint, making EAFs sustainable. Maximizing scrap metal recycling lowers environmental impact. Supporting carbon capture innovation is essential. Technologies to capture and store emissions are paramount. Decarbonizing steel requires collective effort. Embracing a holistic approach paves the way for sustainable steel production.